Alright, let's solve permutations 4. I will assume you've read through the statement. And obviously, if we look at the constraints, we cannot enumerate all the permutations in the lexicographical order till we find the kth one, because k can be very big. So we have to be clever in sort of knowing what permutation to go to. For example, in the first example, n equals 4, k equals 6. We have two valid alternating permutations that start with 1, 2 that start with 2, 2 that start with 3, and 2 that start with 4. Because k equals 6, we straight away know we won't use these two, and we won't use these two, and we will have to use one of these two, right? And obviously here k is small, n is small, but maybe those quote-unquote buckets, right? Maybe all the lists, all the alternating permutations that start with 1 could be 100,000 elements, right? So if you skip those blocks, then you would gain a lot of time, right? That's the idea here. Also, k can be too big, and if k is too big, right, there's only 8 valid alternating permutations here. If k is like 9, then we just expect an empty list. So that's the problem statement and sort of the intuition about how to make it faster. And so the challenge here is to try and measure how big those blocks, those buckets are, so we can straight away go to the one we're interested in. And to do that, I will use two things. I'll use un as the number of alternating permutations of length n, with n over 2 odd numbers and n over 2 even numbers, meaning n is an even number here. I'll also create Vn, which is the number of alternating permutations of length n, except this time I have n over 2 odd numbers and n over 2 plus 1 even numbers. And I'll create Wn, which is the same, except I have n over 2 plus 1 odd numbers, right? So why am I creating those? Sorry. This is because those are linked, and it'll be very easy for me to compute all of them in big O of n. And the recursive relation is not too hard to infer. We have un, which will be, well, we can either choose an odd number or an even number. If we choose an odd number, we have n over 2 choices, times, or if we choose an odd number, then we are in the Vn situation. If we choose an even number, then we are in the Wn situation. Then for Vn, we have to choose an even number, because otherwise we would have a gap of 2 between them, and we wouldn't be able to make an alternating permutation. And we have n over 2 plus 1 possibilities, and then we would be in the situation when we have n over 2, n modulus 2 is 0, right? N is an even number. So we would feel like we'd have to just multiply by un minus 1. Except, because we want an alternating permutation, this is choosing an even number, and then un minus 1 would be allowed to choose an even number as well, right? Which is not what we want. We want to only, at the n minus 1 step, choose odd numbers, right? So we have to divide this one by 2 as well. And Wn is actually symmetrical. We have n over 2 plus 1 odd numbers to choose from, and then we multiply by un minus 1, divided by 2, because we want to impose, we want to force the choice of an even number. And we will just initialize all the values at 0 initially, and that's V, that's W. The only initialization we have to do is U of 0. U of 0 will be selected, will be used by V1 and W1, right? And we want them to have one possibility, right? So we have to put U of 0 equals 2. Otherwise this will be 0 and everything will be 0. So we'll just do U of 0 equals 2. And then for rest, this is just basically, it's very similar to dynamic programming. If I modulus 2 is, so this is if I is odd. If it's odd, then we are in one of those situations. So it means V I equals I over 2 plus 1 times U I minus 1 divided by 2, which is just copying this, right? And else, that means if I is even, then we just copy this. And so U of n, or W of n, will be the number of alternating permutations in total. So if k is bigger than that, then it means there's no valid permutation, right? If we go back here, we can see, for example, here we only have 2 valid alternating permutations. K is 3, so we want to return an empty list. So that's exactly what we'll do. If n is odd, then who do we want to look at? Do we want to look at un? No, we want to look at wn, because there will be more odd numbers than even numbers, because we start at 1. So we'll have to say if k is bigger than wn, actually, then we return the empty list. And else, that means if n is even, then we have to check un. So we'll just do something like if k is bigger than un, we'll just return an empty list. And so already this case should pass. Right, and we can check the first test case that fails is the second one, so this is probably well implemented. Now that we've computed these take big O of n to compute, we need to be able to do the selection of blocks of buckets I was talking about earlier. And for that, again, we have 2 situations: either n is odd, either n is even. So if n is odd, then we'll be interested in wn or vn, right? Those are symmetrical anyway. And we can choose n over 2 plus 1 numbers. And each of those numbers, right, will be what will be in the prefix. And then we have this amount of possibilities. For example, here n is odd, so that's the case we're interested in. How many numbers can we choose from? Well, n over 2 is 3 over 2, which is 1. 1 plus 1 is 2, so we have 2 choices, which is exactly what we have. We can either choose 1 or 3. And how many, what's the size of the blocks? It is un minus 1 divided by 2. And here, that will be 1. Right, because we have sizes of blocks of size 1, sorry. In the case odd, in the case of even, we'll have something similar, and maybe for this example we have, well, how many choices? Well, we have 1, 2, 3, 4 choices, and the blocks will be of size 2. So this block size will be useful, because if the blocks are of size 100,000 and k is 200,000 and 250,000, then we know we can ignore the first block and the second block, and we can start looking at the third block directly. So if n is odd, then the bucket size will be Wn divided by n over 2 plus 1. The number of permutations divided by the number of choices I get for the first element. And just Wn with brackets. And which bucket will I end up in? Well, it depends on k. Bucket will be almost k divided by bucket size. Why do I say almost? Because if we have a bucket size of 2 and k is 2, then we want the first bucket, the 0th bucket, and we want the last element of the 0th bucket. Here, if we do d2 divided by 2, we'll get 1, so we'll go to the first element of the first bucket. Right? Maybe I'm not clear. If the buckets have 2 things each, those are buckets. If k is 2 and bucket size is 2, then I'm looking at this element. But 2 divided by 2 will keep me in the first bucket. So I have to do k minus 1 divided by bucket size. So now if k is 2, bucket size is 2, the bucket I'm looking at is the 0th bucket. When k is 5, 5 minus 1 is 4, 4 divided by 2 is 2, I'm looking at the second bucket, 0, 1, 2. If k is 1, or if k is 2, if k is 1, 1 minus 1 is 0, I'm looking at the 0th bucket, I'm looking at this bucket, so all good. So we have to be careful here with the minus 1. And now we know which bucket we're looking at, and the bucket we're looking at will be indicating what is the value in the prefix, right? If we're looking at the 0th bucket here, it will be 1. If we're looking at the first bucket, it will be a 2. If we're looking at the second, but it's 0 index, we're looking at 3, etc., etc. So it looks like we just want to say something like the prefix number is just bucket plus 1. Right? If we're looking at the 0th bucket, it's 1. If we're looking at the 1 bucket, it's 2, etc. The problem is, after we will have simplified for the first value, we'll recursively call the same function and simplify for the second value, which also have buckets, etc., etc. And the list of allowed values will change, because if we used a 3 here, then we can't use a 3 anymore in the second values of buckets. So we have, first of all, to have a recursive call, but that's easy to deal with. Just permute recursive. Also takes n, it takes k, and we also want the leftovers numbers. Right? What numbers are we still allowed to use? And here we'll just return self.permute rec n, k, and r, I for I in range 1 to n plus 1, because initially we're allowed to take whichever numbers we want to. And so instead of doing this, we'll just say, well, prefix number is minus 1, we don't know what it is, and we'll iterate to this list for I in range length of this, if this I the second thing we have to be careful about is, are we allowed to put even number and are we allowed to put an odd number? Right? Initially, we can put any number we want, but then we can maybe if we put an odd number here, we are only allowed even numbers here. Right? So we also have to be careful about that. So in our recursive call, we'll just add can use odd and can use even. Right? And initially, if n is odd, then we have to if n is odd, we have to start with an odd number because there's more odd numbers than even numbers. So, true, false. However, if n is even, then we can start with whatever we want. Right? This is the case when we have maybe 1, 2, 3, 4, 5. We have to start with an odd number, otherwise if we start with 2, then we have 3 odd numbers and only 1 even number, and that doesn't make sense. And here, this is 1, 2, 3, 4. We can start with an odd number or an even number. We can do whatever we want. So here, we want to check if this is odd and we can use an odd number, then we'll just, this is a valid bucket and we want the bucket valid bucket, so we'll just do something like bucket copy equals bucket, and every time we find one we just do bucket copy minus equal 1, and if bucket copy equals minus 1 we just say prefix number, we found prefix number. Why do we wait till bucket copy is minus 1? Well, because imagine bucket is 0, well, we want to use the first number we can. And so we find a number, we remove 1 from bucket copy, we get minus 1, and so we found the number. And similarly, the same with can use even, so that should be correct. And then this stage we know that prefix number is not minus 1. Right, so this will never happen. Also, because we selected this number, we can remove it from the leftover numbers. It's removed in Python, valid number, prefix number, sorry. This is big of n, right? But n is really small in this problem, so that's really not a problem, right? The only problem here is that k can be big. N is up to 100, so we can go even up n to the cube without any problem. And then we will return, well, the prefix, so this is prefix number, plus the recursive call. Self.permit rec n minus 1, because there's one less number. K minus bucket times bucket size, yes. Why? Because if we are looking at the fourth bucket, then bucket 0, bucket 1, bucket 2, and bucket 3, we haven't used them, so we have to subtract them from K, and this is literally where we're getting a lot of complexity. We pass it leftover numbers, although this could be sort of a class variable, and can use odd. Well, it depends on prefix number, right? If prefix number is odd, then we're looking at can use odd. So if prefix number is odd, sorry, if prefix number is even, we can use odd, and if prefix number is odd, then we can use even for the next iteration. Hope this makes sense. If it doesn't make sense, good thing is we're gonna do almost the exact same thing when n is even, right? When n is even, instead of a bucket size being wn divided by this, well, when n is even, we're looking at u of n, and we have n over 2 choices for odd numbers and n over 2 choices for even numbers. So in total we have n choices, and we want the size of a bucket. The size of a bucket will be un divided by n, right? Maybe if I show an example, here we have un equals 8 because there's 8 possibilities, n equals 4, 8 divided by 4 is 2, so the block sizes, the bucket sizes is 2. So instead of this, we will have something like u of n divided by n, and we know this will work because un is divisible by n, because un is literally n over 2 times this plus n over 2 times this, but these two are symmetrical, they're the same, so un is actually n times vn minus 1. The bucket, this doesn't change, right? The bucket we choose is k minus 1 divided by bucket size. It's the same explanation. And then we want to get the right number, so I don't think that changes either. Let's think. We copy bucket. Initially we put -1, we iterate till we find the bucket number. So yeah, that should be the same. We can make sure prefix number was found, we can remove it, and then we can call our function recursively. Here, again, I don't think anything changes. n-1 because we have more, we used one number, so we only have n-1 numbers anymore. K minus bucket times bucket size, leftover numbers that we removed, and the can use that updated that way. So I don't think anything changes here. But we have forgotten, because now this has become a recursive call, we have forgotten the base cases, right? And the base cases are, if k equals 0, then I just return an empty list. So that means maybe I found my prefix number and I'm looking at the next iteration, but in the next iteration I found the right number, so k is 0, so I just return an empty list. And if n is 0, I'll also return an empty list. An example of n equals 0 would be if I have k is 0, sorry, if k is 1 and n is like 50, well, the optimal sequence is 1, 2, 3, 4, 5, all the way up to 50. And every time here, we will have a bucket size that's, the bucket we'll choose will always be the first bucket, the 0th bucket. So k will never decrease. So that's why we need this base case of if n is 0, return the empty list. So I hope this is correct. Let's check. Don't have any mistake on the test cases. Let's try and submit on Leetcode. And that's accepted.